and welcome to my YouTube channel PSpice Tips. Today I'm going to show how to define a distortionless transmission line using also a lossy transmission line. For that I have used this component from PSpice component Basics und dann T-line lossy. If you remember, for a distortionless transmission line, this condition must be a gift, and for that I make double click here, and what I define is a capacitance of 4 picofarad, a conductance of 0.001, an inductance of 40 nanohenries, a length of 3.75 meters. Don't forget to define this parameter in meters, and a resistance of 1. So with these values, this expression is a gift. So we are going to define a distortionless transmission line for a frequency of 10 megahertz. Okay, this is my circuit. In this circuit, you can see that I have, for example, a load resistance, a resistor of 100 ohm. At the same time, I have here that the characteristic impedance, if you calculate using the mathematical equation to describe transmission line characteristic impedance, you get a value of 100. And if we calculate the input impedance in this point, we get that this is equal to the characteristic impedance. So in this point, in this input, we are going to have 9.09 volts. Why? Because we are doing here, we have here 10, and then we have here the characteristic impedance value, in this case 100. So if you calculate here the voltage, it will be 9.09 volts, taking into account that here we have 10 volts. Okay, you will see that in this point we have fewer voltage than in this point. Why? Because in this case we have a distortionless, but we have losses in this transmission line. That's why. Okay. At the same time, if we calculate the propagation delay, mathematically we will get a result of 1.5 nanoseconds. Let me simulate. The simulation will take more or less 30 seconds. So here it is. Much faster was it. As you can see, let me make zoom here. I'm going just to increment this area here. You can see, for example, let me take the cursors. You can see here, for example, that's the input signal. Let me show you. This is the green input signal before the transmission line. Red is after the transmission line. You can see that we have here 9.09 volts, exactly what we have calculated for the input voltage. And after the transmission line, let me take it, we have 8.75 volts. Okay, so we have here more or less 20 millivolts, what we lose in this transition. Sorry, 200 millivolts. Okay, in this transition. But well, just for you to know, because as I told you, we are not in this case in a transmission line without losses, but in a transmission line without a distortion. Okay. At the same time, as I told you, if we calculate here the delay, we can see that it is approximately 1.5 nanoseconds. I hope it helped you for you to use transmission lines, for example. If you have any doubt, then just let me know. Thank you, and bye bye.